Hello, welcome to my YouTube channel Easy Aviation. Here we discuss about the simple short topics about the aviation field. Today's topic of discussion is gliding, as you can see on the screen. So gliding is a phenomena which undertook under the influence of gravity, that means without the usage of engine. So as you might be aware that an aeroplane has four forces which are acting on the aircraft, that is thrust force, the drag force in the backward direction, lift force and the weight force. So in the gliding, when the aircraft glides, thrust is equal to 0. That means engines, either there are some emergencies, engines are not working or the engines are cut off. So the aircraft is approaching the ground for the landing, and this phenomena is known as gliding. So as you can see, there is a schematic diagram with all the forces acting on it. A plane is approaching the land. This line signifies the ground. This is the flight path, or in the opposite direction you can say this is the relative airflow which is acting in this direction, in the direction of arrow. The angle between the ground and the flight path is known as gliding angle. I'll write it here, gliding angle. Okay, so if you do a simple mathematics, if this is gliding angle, this is also equals to alpha, and the angle between the lift and the relative airflow, I'll just write it here, relative airflow. This angle between the lift and resultant airflow is 90 degree, and this is alpha, so this is 90 minus alpha. And the angle between the horizontal line and the resultant force, the force between lift and drag, is also 90 degree. That means this angle is also alpha, that is gliding angle. Okay, I'll just draw a parallelogram here connecting the drag and lift and resultant air force, resultant force as the diagonal. So this is also a drag force acting in this direction. This is lift acting in direction, and as you are aware, tan alpha is equal to perpendicular upon base, that is drag upon lift. Okay, so this equation or this formula is very important. I'll just write it here, tan alpha is equal to drag upon lift. So this means that lower the value of drag to lift ratio will resultant into the lower value of tan alpha. That means if the drag to lift ratio is very less, the flatten will be the gliding angle. So it will take more time for the aircraft to easily glide and do a control landing. As I said, drag to lift ratio should be less, or you can write it as lift to drag ratio, which is a very important factor while designing a aircraft. So if the lift to drag ratio is very high, which is corresponding to a flatter gliding angle, that means farther the aircraft will go. So this is a very important parameter to understand. So I'll just explain the relation between the lift to drag ratio and the angle of attack. This I had also covered in the previous lecture. So this curve behaves like this. So there is a particular angle of attack, let's say alpha, efficient alpha, we'll write it as theta, because alpha we have already used. So theta, efficient theta, at which the L by D ratio is maximum, which is the angle at which the aircraft will cover the farthest distance, or the aircraft will glide to the maximum point. Any angle of attack, either it is lower than the efficient angle or more than the efficient angle. I'll just write it like, let's say this is minus 4 degree, 0 degree, 8 degree, 10 degree and 12 degree. So let's say aircraft is flying at 10 degree angle of attack or at 4 degree angle of attack. There is a lift to drag ratio which will be lower than the lift to drag ratio of the efficient angle. So this L by D ratio, at which this angle of attack at which the lift to drag ratio is maximum, is of very much consideration during the gliding. I'll just take another page to discuss about the other factors. First we have already understood tan alpha is equal to d by L. So d by L should be less, or L by d ratio should be more, or to be the best, and there is a corresponding angle of attack for the same to give the best gliding angle. So this is the theory about the gliding angle. I'll discuss about 2 points. First point will be the effect of weight on gliding. So as we are aware about the lift equation, lift is equal to half rho v square s into coefficient of lift. So rho is the density of the medium, velocity is at which the aircraft is flying, v square, s is the surface area of the aerofoil. I'll cover this lift equation in detail in the later section, and cl is the coefficient of lift. So as we are making the coefficient of lift constant because we are flying the aircraft at particular angle of attack, or you can see the best efficient angle to get the L by D ratio maximum. If we increase the weight, the lift has to be increased, and if CL is constant, S is constant, surface area can't change in flight, density of the medium is constant, that means the velocity will increase automatically to cater for the lift if we increase the weight. I hope you understood this point. Second is the endurance of glide. So endurance of glide, first point is the angle of attack should be the efficient angle of should be at the efficient angle which I discussed earlier, which give you the best L by D ratio, and this will give you the best endurance. Further, if you want to be in a flight for longer duration, endurance is the time duration at which without engine you can be in the air. So if you want a better endurance, your overall velocity should total velocity of the aircraft should be less. That means the aircraft should be lighter, or weight should be on a lighter note. So these are the two factors which will give you the endurance of the glide. And I have discussed about the weight, how the effect of weight gives you a higher velocity when the aircraft is gliding. So here I complete my session of gliding. I hope you understood the point. If any doubt, any specific query about this topic, please put it in comment section. Thank you. Thanks a lot to join with me. Thank you.